Okay guys, welcome back. Here is our next lesson. We have notes number 40 and we're looking at the graphs of the three additional trig functions, cosecant, secant, and cotangent. So what we'll do is review the three graphs we learned last time and then add on the new ones. So let's review how we graph y equals sine x. First of all, remember the width of one cycle is 2 pi, and that's called the period. So the period is 2 pi. The amplitude is 1, that's the distance from the middle to the top. And remember that the sine graph goes through 0, 0, so that's a good starting point. And then the sine of pi over 2 is 1. I need to label my y-axis here, 1, negative 1. So we have this point, and remember the way I like to think of it just as a shortcut is you go middle, top, middle, bottom, middle, and that completes one full cycle between 0 and 2 pi. And then you can replicate that on the other side. So middle, bottom, middle, top, middle, and that completes one additional full cycle on the other side. So there you see two full cycles of the sine graph. Okay, what about the cosecant graph? Remember that cosecant and sine are reciprocals. So let's start with x equals 0. What's the reciprocal of 0? Undefined. So where it's undefined, you're going to have a vertical asymptote on cosecant. Let's move on to pi over 2. For pi over 2, the sine value is 1. What's the reciprocal of 1? 1. So cosecant will be 1 as well. Label that y-axis there. Okay, let's move over to pi. The sine of pi is 0. So the cosecant of pi is undefined, so we have another vertical asymptote. Let's move over to 3 pi over 2. The sine of 3 pi over 2 is negative 1, and the reciprocal of negative 1 is negative 1, so cosecant will be negative 1. Now let's move over to 2 pi. Again, the sine of 2 pi is 0, and the reciprocal of 0 is undefined, so another vertical asymptote. So what you're going to see here is a pattern that alternates vertical asymptotes with points at a height of 1 and points at a height of negative 1. So if we go to the other side, we're going to have a point at a height of negative 1, a vertical asymptote, a point at a height of positive 1, a vertical asymptote, and so on. Here we're just stopping at 2 pi and negative 2 pi, but in theory it would just continue on infinitely far in both directions. Now let's look at what's happening in between. So, looking at the sine graph, if you're at this point right here, and you're working your way away from it, the sine values are getting smaller. They're positive, but they're getting smaller. Same thing on the other side, positive numbers getting smaller. What would happen to the reciprocals? Those would be positive numbers getting bigger. The reciprocal of a smaller number is going to be a bigger number. And so what we're going to see is positive numbers getting bigger on both sides of that point that was plotted. What about, looking back at the sine graph, what about this part? Here we have, moving away from the point at a height of negative 1, we have negative numbers getting closer to 0. What about their reciprocals? Those would be negative numbers getting farther from 0. So it would look like that. So you're going to find a series of alternating U-shaped curves going up and U-shaped curves going down. And that's what this cosecant graph looks like. Kind of strange. Now, what's the period? So what's the width of one cycle? One cycle has one U-shaped curve going up and one U-shaped curve going down. So the width of one cycle is 2 pi. So the period is 2 pi, just like it was for the sine graph. And what's the amplitude? Amplitude is the distance from the middle to the top. There is no top, so it's undefined, just like it was for tangent. So now that we have that idea, we can go ahead and do the same sort of thing to find out what the graph of secant x looks like. So let's start with cosine. Remember, cosine goes through, first of all, I should label my axes, and you can feel free to pause so that you can draw your graphs and get ready to go. The cosine graph goes through the point 0, 1. We start at the top. Then we go down to the middle, down to the bottom, back to the middle, and back to the top, connecting those with a nice smooth curve. We can repeat that on the other side. Middle, bottom, middle, top. Connect with a nice smooth curve. Okay. So then what does, oh, let's fill this in, period 2 pi, amplitude 1. What does the secant graph look like? We're going to generate this just like we generated the graph for cosecant. So let's look at what's happening here. Cosine is at a height of 0 when x is pi over 2. So secant will be undefined. So we'll have a vertical asymptote. Where else is cosine at a height of 0? At 3 pi over 2. So at 3 pi over 2, secant will have a vertical asymptote. Where else is cosine at a height of 0? Negative pi over 2. So secant has another vertical asymptote. So you can see the vertical asymptotes are pi units apart. And what's going to happen in between? So at x equals 0, cosine is at a height of 1. The reciprocal of 1 is 1. So secant is also at a height of 1. When cosine is at x equals pi, it's at a height of negative 1. The reciprocal of negative 1 is negative 1. So we're getting the same thing we got for the other graph. You're going to have points that alternate between a height of 1 and a height of negative 1, and they have asymptotes between them. And then you're going to get U-shaped curves going up and U-shaped curves going down, and they alternate. Now for this one, if you're stopping at negative 2 pi, you're just going to have half a curve on the left side, and if you're stopping at positive 2 pi, you're going to have half a curve on the right side. If you're not stopping there, if you were continuing, you would just continue to have more of that curve. The period is the width of one cycle, so one cycle would be one curve going up and one curve going down. So the width of that is 2 pi, so the period is 2 pi. And just like the graph of cosecant, the amplitude is undefined since there is no top. It just goes on infinitely far in the y direction. Okay, now let's take a look at the graph of cotangent x. So we start by graphing tangent x. So remember that tangent goes through the point 0, 0, and then we have a vertical asymptote at pi over 2, and another 0, and another vertical asymptote, and another 0, etc. Keep doing that. Oops, I'm off by 1 there. There we go. So remember that the asymptotes are pi units apart. They're a distance of pi apart from each other. Okay, and then remember the curves look like this. They swoop up, swooping up, swooping up, and if you're stopping at 2 pi, you're going to have half a swoop over there. Stopping at negative 2 pi, you're going to have half a swoop over there. The period is pi because the width of one cycle is just pi units, and the amplitude is undefined because there is no top. It just goes on infinitely far in the y direction. Now for the cotangent graph. Everywhere, remember back in the previous graphs, so let's take a look at everything so far. Everywhere sine was 0, cosecant was undefined. Looking at this one. Everywhere cosine was 0, secant was undefined. So everywhere sine was 0, cosecant had a vertical asymptote. Everywhere cosine was 0, secant had a vertical asymptote. Carrying on that theme, everywhere that tangent is 0, cotangent will have a vertical asymptote. So vertical asymptote at x equals 0, vertical asymptote at x equals pi, vertical asymptote at x equals 2 pi, at negative pi, at negative 2 pi. So you have the same amount of vertical asymptotes and the same spacing between them, pi units apart, but they're not in the same place as they are for tangent. They're shifted over. That's supposed to say pi units apart. It doesn't look very clear. And then in between all of those, you're going to have zeros. Okay, now what does the curve look like? Well, When you have numbers that are going up, their reciprocals are going down. And so these are going to be downward swooping curves. Downward swooping curves, and we don't go through the point 0, 0. So these are just things to keep in mind. The period is pi, the width of one cycle, and the amplitude is undefined. There's no distance from middle to top. Okay, now that you have seen all of those, let's do a little bit of practice. Practice graphing y equals cosecant of x on the interval from 0 to 4 pi. Okay, so draw your graph, split it up at 2 pi because the period is going to be 2 pi. Split that into 4 equal parts, and then split the next interval into 4 equal parts. Put a 1 on your y-axis and a -1, and then picture the sine graph. Okay, so I'm going to draw the sine graph first. I'm going to see if I can make it, well, I should have selected a better color, but okay, I'm going to draw the sine graph in yellow. Picture it. You could make it really pale or use a colored pencil or something. So this is the sine graph. Okay, now what we want to do is everywhere that that is 0, we put a vertical asymptote. Everywhere that that is 1, we put a 1. Everywhere that that is -1, we put a -1. Then we have curves going up and curves going down. That's how you draw cosecant. You don't necessarily have to memorize the shape, but you need to know how to get it from the shape of the sine graph. So then you would just ignore the yellow one. Let's see if I can just erase it. Something like that, okay? Let's do the same thing to graph the secant graph. So we're going on the interval from 0 to 4 pi again. Put a 4 pi out there. Put a 1 and a -1 on your y-axis. Split it up, put a 2 pi there since the period is going to be 2 pi. Break up your 2 pi into 4 equal parts. Break up the next section into 4 equal parts. Picture your cosine graph. Remember, cosine starts at the top. So top, middle, bottom, middle, top, middle, bottom, middle, top. Connect that and you get your cosine graph. Then for secant, everywhere cosine is 0, you have a vertical asymptote. Everywhere sine is 1, or sorry, everywhere cosine is 1, you have a 1. Everywhere cosine is -1, you have a -1. And then from there, curves going up, curves going down. As many as it takes to go through the interval you were asked to do. Okay? Then I'll just get rid of my yellow one, get rid of my cosine graph, and there's the graph of secant. Let's practice graphing the cotangent graph on the interval from 0 to 4 pi. It's not as important to put the 1 and the -1 on the y-axis because we weren't really using that for anything. Go ahead and split it up into increments of pi, and then split those. You can just split those in half. So let's picture the tangent graph. Tangent went through 0, 0, had an asymptote at pi over 2, alternating zeros and asymptotes. So that was what tangent looks like. Tangents in yellow. So let's go ahead and do cotangent. Everywhere tangent was 0, cotangent is undefined. So everywhere tangent has a 0, cotangent has a vertical asymptote. And then everywhere tangent had a vertical asymptote, cotangent has a 0. And then these curves are going to go down instead of up. So you're just going to have to ignore my yellow ones. I know it looks messy, but the yellow was just to get us going to know what to do, and the red is actually the curve we want. Okay, great. So your assignment is to graph each of the 6 trig functions. Notice we have all 6 of them here on the interval from -2 pi to 4 pi. So for some of them you're going to get 3 full periods, and for some of them you're going to get 6. I should say 3 full cycles or 6 full cycles, depending on which function it is. Let me know if you have any questions. Thanks, everybody.